In this video, I'd like to talk about the math question of the day for Friday, July 7th, 2023. And with this problem, we need to find the length BC in triangle ABC. And from there, we just need to round that to the nearest tenth. So a question like this will typically be seen in a pre-calculus class, though you might see it in a trigonometry class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And we need to find the side BC. So let's start by just labeling that. We can call this X, or actually let's call it little a since it's opposite the angle A. Now, a question like this where we know two of the angles and one of the side lengths, we can use the law of sines to determine one of the other side lengths. And that's particularly useful when we do not have a right angled triangle, like in this case here, since if we want, we could figure out this missing angle here by adding these together and subtracting from 180 to see that this would just be a 33-degree angle. And since none of these are right angles, we will need to use the law of sines. And just as a refresher, if we have some general triangle here, that's not a right triangle, and let's say that we have angles A, B, C, and then opposite angle A will be side length little a, opposite B will be side length little b, and this side here, opposite angle C, will be little c for the side length. And the law of sines just states that the ratio of, let's say, A to sine of angle A, this is equal to the ratio of side length B to the sine of B, and this is also equal to the ratio of side length C over the sine of C. And if you want, you could flip this. You can have sine A up top and little a down below, and same for the other ones. So we can use this law of sines to figure out our missing side length here. And if we want to label this, this could be length B right here. And let's set up our proportions, these ratios between angle A and side A. So we'll use the sine of this angle. Let's write that down. We have this missing side length A divided by the sine of the angle opposite it, which is 67 degrees. This is equal to the ratio of side length B, which we know is 20, divided by the sine of the angle opposite side B, which is 80. And if we wanted to, we could involve side length C at some point later, though we don't need to find that for this triangle. So from here, we can just solve for A. So let's multiply both sides of the equation by the sine of 67 degrees. So that we get A is 20 multiplied by the sine of 67, all divided by the sine of 80. And at this point, we can just plug everything into our calculator, and we need to round this to the nearest tenth place. And just remember that when you plug this into your calculator, make sure your mode is in degree mode and not radians. And when we evaluate this, we find that A is 18.6941 and so on. It will be irrational since the signs are both irrational. So we can approximate this to the nearest tenth place. This 6 is in the tenth place, so we'll have to round it up since the next number is a 9, and that's bigger than 5. So we have 18.7 for our final answer. And this should make sense because this side length B is the largest side. The largest side is always opposite the largest angle. So this side length A needs to be less than 20, which it is.